and welcome to this edition of GeoTalks Express. Today we're going to be talking about what's new with Geographic Calculator version 2020. My name is Sam Knight, and I'm here with one of our QA staff, Scott Weber. And we are going to be talking about the new features of Geographic Calculator 2020. What we're going to do is a typical webinar format here today. You are all in listen-only mode right now. If you do have a question that you'd like to answer, feel free to use the questions panel, typically on the right in your GoToWebinar screen, and we will try and address some as we're going, and if not, we'll have some dedicated time at the end of the session where we'll focus on questions. The session is being recorded. It usually takes us just a couple of days to get the video edited and turned around, but this will also be posted right back on our website for viewing at a later date, also for those folks who may have missed the session today. So today, the agenda, we're going to take a look at Geographic Calculator 2020. We have a lot of users signed up who are not presently calculator users, so we're going to be starting with a general overview of the application. We're going to take a look at all the common jobs, so the things that folks are typically familiar with, as folks that are already users are going to find these the jobs they're working in all the time. We're also going to take a quick look at some of the specialty jobs and some of the newer widgets that have been added to the application, and then really today is all about the new features. So that's primarily where we're going to spend most of our time. And again, we're going to have some dedicated time for questions at the end, but please do feel free to put in the questions into the questions panel in your GoToWebinar controls. Okay, so Scott, I believe you are here with me.
I am.
All right.
Good morning, everyone.
Let me just pass you over some control. Let's give that a try. Can you wiggle the mouse? All right, looks like you've got some control. Yep. So Scott and I are going to be handing back and forth here this morning. And again, the first thing we're going to start is just a general overview for folks of you who may be new to Geographic Calculator. The breakdown of the application is that it is a geodetics calculation application. So all of the jobs that you see down the left-hand side of the interface here in the project manager, they're all for performing some kind of calculation, some kind of coordinate conversion, datum transformation, distance and heading calculations, any number of different things. So we're going to start by focusing first on the jobs that are at the top of the interface here. These are what we think of as sort of our standard jobs, and then down into some of the special features a little bit farther below. This is where we get into particular combinations of things. So we're going to focus just first on the basics, and then we'll touch through some of the special features. But don't be intimidated by this list. There's a lot of reuse of the stuff in the special features for particular cases. There are a lot of very nuanced things that we do here in the calculator. So we're going to start with the interactive conversions panel. This is really the main workhorse of the application. This is one of the two most common jobs that folks are using the Geographic Calculator for. As you can see by the interface, it's for a single point operation. So we have a point on the left and a point on the right. Either of those points could be the input or the output, but what this job is for operations on those single points. So either conversions, you'll see the operations we can choose up in the top left there, either conversions or forward and inverse. Now forward and inverse are calculations involving distance and heading across the surface of your coordinate system. So those are a forward would be where we enter in a starting coordinate and we supply a distance and an azimuth away from that coordinate, and it would calculate for us the ending location. The inverse is just the other way around from that. Our input is actually the start and end, and the output of that is the distance and azimuth between the 2 points. So for a very simple conversion here, we're going to use the conversion job as a means of setting up how we operate with coordinate systems. The Geographic Calculator is built on the largest commercially available database of coordinate systems. So the boxes down here at the lower half of the job, all of these blue boxes, are where we set up the selection of our geodetics. So we're going to double click on any of those boxes to open up our pickers. And you'll see some choices here. And these are some basic user preferences that I have turned on, set to ask me right now. Whether you want some help selecting a coordinate system based on a map control, or whether you just want to get right into it and pick your systems through the folder system and the names. Just as an example here, I'll bring that up. I'll say, let's use that map helper. This is going to bring up a simple world map. It can be as simple as just clicking on the map to figure out where you want to be working, and you can just click anywhere on the map, and it will filter out that list of coordinate systems based on the geographic point or a box or polygon that you've drawn on the map as your working area. Now, I canceled back out of there, and if you come back in here, I'm just going to double click on there, and again, the same prompt. This time I'm going to say no, let's not use that map control. This is the way I typically work. What this does is it lets you right into the database, and you browse instead through all of the full folder system, and you can pick anything in the world, not limited by the point that you've supplied there. So this is a basic user preference, and a lot of folks like to work one way or the other in here, and there's not really any better way to go. So for the system that I already had set, it's going to take me back to that, and so I happen to have NAD 27 there. So that opens me up to the North America folder where the North American datum of 1927 lives. And if I were looking for that, I can start in the most compact view. You'll see there's a category set of coordinate systems here. Geodetic is our lat-long systems. Projected are all of our projected maps like transverse Mercator, Lambert conformal conic, Mercator, all those sorts of things. String, fitted, and geocentric are a little bit more specialty for some folks. So in particular, starting off with the fitted systems, we'll be talking about those again in a little bit. Fitted systems are for engineering type grids, very commonly used in the mining industry, very commonly used for airport surveys on the ground positions, very commonly used in the surveying world. Any localized data that you have can be mapped up and establish a relationship between a control data set and your local fitted coordinate system that you're going to create, and you populate these. So these are all going to be user created. Geocentric coordinates, these exist all over the world. These are also called three-dimensional Cartesian coordinate systems. Some folks simply call them XYZ coordinates. The origin of these coordinate systems is the center of the Earth, the geocenter. It's typically going to be used in gravity-based systems, things like satellite operations. It's actually the core of how GPS technology works. So these can be used for a number of different purposes, and you'll see there's a full category of these all around the world. And then back down to string coordinates. And now string coordinates are a very specialized set of coordinate systems that take either a lat-long or a projected coordinate system, and it formats the values. So one of the common ones that we use here in the US is called US National Grid. There's another one called Military Grid Reference System. Folks over in the UK have British National Grid. And these are all similar systems in that they take an actual projected coordinate system and then they wrap it up in a grid structure, and the coordinates don't actually look like Cartesian values anymore. They have combinations of letters and numbers that break down into grid cells within those projections. So very specialized systems, but we have those in here as well. So for our NAD 27 example that we're looking at here, we can pop that open and view its information. All of the coordinate system parameters are fully exposed in the Geographic Calculator. This is one of the things a lot of new folks like about using the application, is that any parameter that you've got in here, you can crack open, such as the datum. We see it's on the Clark 1866 ellipsoid. The prime meridian is Greenwich. You can get history information about where those parameters have come along from the EPSG database. We can link those up against other databases of coordinate systems. So you'll see under the identification panel of there, cross-references with the unique identifiers to locate this same coordinate system in other databases or other software or other standards databases, such as EPSG, for example. You can basically find all of the full information you need about any set of parameters of whether it's a datum, an ellipsoid, linear unit, any of those sorts of things. So I'm going to come back and make our selection. So we have a sample coordinate here. And the basics of how coordinate transformation works in the Geographic Calculator is that we take the data that you give it. So in this case, on the interactive job, it's just simply a lat-long position somewhere in the world. And this point is a nice round number for us, somewhere off in the woods here in Maine. And we're going to say that 44 north and 70 degrees longitude, west longitude, in the NAD 27 coordinate system is where we're working. And we want to take that to a common coordinate system on the right. So this is a NAD 83 UTM, Universal Transverse Mercator Zone 19 north, which is a very common system for folks using in our part of the world here. You'll see that all the coordinates up at the top of the page are red. I already had some values saved in here. They turn red to indicate that I've been messing around with my interface and something may not match here anymore, just as a quick warning. So we have our coordinate system set on the left and right, and then we need to establish the transformation, how we're going to get from datum to datum in here. So our horizontal datums here are NAD 27 on the right and NAD 83 on the, NAD 27 on the left and NAD 83 on the right. Those are distinctive datums. They have different ellipsoids under them, and they are also different sizes. So they're not just different in name, but they actually have different dimensions for both the equatorial axis, the semi-major axis, and the polar axis, the semi-minor axis. So we need a transformation to link up the geocenters in there and help us hop from one of these models to the other. And that's where the center box comes in, the coordinate transformation. Now, we're going to be talking a lot about the coordinate transformation box today because this really gets to one of our major new features in the Geographic Calculator. For a very long time, basically 14 years now in the Geographic Calculator, we have broken off the coordinate transformation from the datum. Many other software packages have the datum transformation or coordinate transformation associated with the datum itself. So when we select NAD 27 over here on the left, that would already come with a transformation. That is one model of datum transformation called early bound datum transformations. And we're going to be talking about that a lot today, but I'm going to move right past that for now. We're going to come back to it later. So the way the calculator has operated for 14 years now is with what we call late bound transformation. So the transformation is a separate entity, and that is what this middle box here helps us make the choice of. So with our disparate datums here on input and output and some coordinate data fed in, we know where in the world we're working, and we know what combination of systems we're looking for a path between. So I'm just going to double click on the coordinate transformation box here, and the calculator is going to spin me up a list of all of the ways that we can get between those two systems, and it's going to give me some additional information to help me make a better choice about those. So we're not just stuck with a single default mechanism in here. What we're going to be doing is dynamically choosing based on that location that we have and based on the combination of systems that we have. So in this case, we'll see a very quick list of transformations. So we actually have about 5 different ways we can get between those two systems. And you'll see there are varying areas of use, but they all encompass the area that we happen to be in here in Maine. You'll see the methods. Some of them are single transformations and some of them are double transformations. So it does 2 things to get to that last step. Very importantly, we have the accuracy information. So an implicit part of datum transformation is a slight loss of accuracy. It's just how datum transformation works. Doesn't matter what tool you're doing that transformation in, transformation does manipulate your data. So the accuracy statement here, basically, the tighter the accuracy, the better the transformation is going to be for that data. So in this case, I see that top one on the list here, sorted by accuracy, is the NAD27 to NAD83 #1 transformation, and that name comes from the EPSG database. We can see the EPSG code for that transformation. It is accurate to 15 centimeters, and if we want to see a little more about that, we can right-click on that and open its information as well. So the parameters that we have in here are a grid file lookup. You'll see the parameters here are a NADCON method, and that is the United States National Survey Standard. And it uses a particular set of tables here, CONUS.LAS and CONUS.LOS. Those are two lookup tables provided by the National Geodetic Survey here in the States, and it is our national survey standard, or was until recently. We'll be talking about that a bit later as well. So I'm going to say this is the one that I want to be selecting. I can compare its identification information, just double check that it really is what I think it's going to be, and make that selection. So back on our main screen here, we've got our coordinate transformation just about complete, and I can hit calculate. You'll see all of the fields turn black, the coordinates settle out, and we have our completed output transformation. So our coordinate position is now in our new system. We can then go on and either do something like print a report or export the point out, write it down, however you want to get that out of here. That basic structure of the application is where we get into the rest of the work. So all of the coordinate transformation that we have here, the blue controls at the bottom of the screen, are the thing that's going to remain constant. And then we're going to get into a number of other types of jobs that are for different types of data. Really, it's only the differing data that is the unique part. So over on the point database conversion, this is where we handle things like spreadsheets. This is where we handle mass conversions of common files, such as, you'll see this is an Excel file that we have loaded in here. This is a common piece of data we use in our demos. This is a file listing all of the public boat launch areas around the state of Maine. It happens to be in UTM Zone 19. And a common thing for folks to do is convert that over to lat long so that they can put it in a GPS. This conversion is done en masse, so we can go right down those columns in the middle. And likewise, on the point database conversion, we can do that on any type of tabular data that we have. So there's about, let's see, probably about 10 common formats that we work with in here, things like Excel sheets, ASCII data like CSV files, tab separated values. ODBC-based database connections can come in here as well. You can define custom text schemes to bring these in here. One of the newer formats that we've added is ODS, that's the Open Document Standard, commonly used in the OpenOffice suite. It's an open source tool suite similar to Microsoft Excel. But all of those same things that we do to one single point on the interactive conversions, we can also do here on the point database conversions. You'll see there are actually 5 different types of point database jobs. And to answer a question that came in just a little bit earlier about doing forward and inverse en masse on groups of points, this is where we can actually do that here in the point database forward and inverse job. Everything we can do on that interactive single point, we can now do either in series, going from one set of points to the next set of points, or we could go from one set of points to a new set of columns. So we can either have disconnected waypoint series, or you can go down a whole series of points in line. Point database forward and inverse, scale and translate. It allows us to do a manual transformation. This is a little more technical, a little lesser known part of the application. This is where we can do things like Helmert 4-parameter transformations or conformal 3D transformations on a set of data. Point database best fit, we'll be talking about a little bit again later as we talk about one of the new best fit functions. This is where we establish the relationships between those control data sets and our things like local survey grids, mining grids, airport grids, those grids we were talking about earlier. And the last point database job is a datum transformation derivation job. So this allows us to map up a transformation between two latitude-longitude systems. So in this case, we have control data in WGS84, and we have control data in Beijing 54 coordinate system. It's a common derivation that geodesists are doing working in China, trying to establish a better transformation in a localized part of the world. Getting a little bit more specialty here, seismic survey conversions. So if you're working in the seismic surveying industries, Calculator has several jobs here. Conversions are one of the things we consider sort of our mainline jobs because there's a lot of folks working with these. This gets into the SEG formats, the UCOA P190 formats, the modern P111 version of those, but these are all about seismic surveys. This has a number of streamline tools that allows folks to work with this very specialized tabular data format. And down in our specialty sets of jobs, you'll see there are some other particular variants of those. We have some quality control that we do on those, and we do a lot with the conversions on them. Something a little bit more for everybody is our vector job. So the vector data conversions allow us to work with about 20 different vector formats. Just pull up the list there so we can see some of those. So everything from AutoCAD out to MicroStation, shapefiles, KML, GML, LiDAR formats, a little bit of everything down there. Vector formats allow us to do those very quick transformations that may or may not be available in other software packages. The reason we might do these here in the Geographic Calculator is to support types of transformations that are not readily available in other applications. I see some questions coming in about the relationship here between Geographic Calculator and Global Mapper, and why we might want to do this in Global Mapper when that's a very efficient tool for that type of work as well. The main reason for that is Global Mapper has a much simpler geodetics engine under the hood. It is definitely capable of doing transformations, but there are a number of types of transformations that it is not able to support with the engines that it has in its use. The projection tools and the transformation tools that are built into Global Mapper are geared a little bit more for the everyday mapping kind of work, and not necessarily the high accuracy positioning work that takes a bit stronger command of what is going on to be able to make those choices. The calculator's engine allows us to do that. And we do actually have tools here that bridge a Geographic Calculator with Global Mapper. And let's just pull up Global Mapper here real quick. Global Mapper, for those of you who are sort of calculator purists, Global Mapper is our desktop GIS application. It does a lot of the analysis and visualization type operations, common mapping layout type applications, LiDAR analysis, terrain modeling, a number of different things. Bringing those two worlds together, here in Global Mapper, you'll see there is a little toolbar that says Enable GeoCalc Projection Mode. GeoCalc projection mode basically replaces all of the native coordinate transformation abilities in Global Mapper and adds on basically all of the complex datum transformation methods that we have in here, adds in a number of projections, and really lets you dial in the control of the selection of those datum transformations. It applies all of the admin tools that we have over in Geographic Calculator for making choices of transformations and projections, and really sort of soups up the power of the geodetics in Global Mapper. It gets us the best of both worlds. So you get the visualization tools, the file format support of Global Mapper, its main core features, but it adds on things like vertical datum transformations. It adds on NADCON5 support and a number of those more complex geodetics operations. That does require a license of both applications, but it's fairly simple to get going. They detect whether or not they are on the same machine. And if you have any particular questions about getting set up with Global Mapper, if you are a user of both of those applications and you want to get GeoCalc mode set up, definitely feel free to reach out to our support team for that, and we can give you more specific guidance on bridging the tools together. So back to the calculator's vector job. Again, this supports about 20 of the common vector formats, supports those powerful transformations in between each other. And it also allows a batch use. So all of the tools in Geographic Calculator have a lot of batching ability. Not really going to spend a lot of time on that today, but just know that anything that we can do in a single operation job, we can also do in a very powerful batch mode, getting out to thousands of files with complex transformations going on in there. Last up for our regular jobs here, the Raster Transformation Job. This goes way back in Calculator's history. When I first started with Blue Marble, we used to have separate applications where the raster tools were all off in another application. The vector tools were all in their own application. We've since a long time ago brought those back together. Raster, vector, point databases, all right in the same place here. This does the same type of operations that you expect from a raster tool. It applies all those same powerful transformations. And here we're dealing with, again, another set of raster files. You'll see the list goes on there. All the usual suspects from JPEG, TIFF, GeoTIFF, to the more powerful formats like Mr. SID, JPEG 2000, ECW, and so on in there. Again, applies all those same coordinate transformation tools to those common raster formats. And again, likewise, we very frequently get a lot of questions about why do we want to use Geographic Calculator versus using Global Mapper when they do some of those same operations. And really, it's the same reason. It's the things like the georeferencer tool that we have here in Geographic Calculator. Some folks like working in the tool in here a little better. Some folks like working in Global Mapper a little better. The transformation support is really the main thing here. Calculator is all about those very high accuracy and precision transformations. Those are those mainline jobs. So again, we're gonna touch a little bit back through some of these jobs, and we're going to be talking about some of these new features that we have in here. Let's see. Scott, I think you're up here to tell us a little bit about some of the under the hood changes that we've had in the calculator. Is that right?
Yeah. First off, I want to mention that we are now offering a single user floating license that can be moved between machines and supports remote desktop protocol. So that's new with this release. This was implemented for customers who need access to Calculator from another computer, as working remotely is becoming the new norm for many users. So that is something to keep in mind. And the way that works is, I'll just drive here. If we go to the license manager, if you have Calculator licensed on one machine, you bring up the license manager and you would click this remove button. I'm not going to do that. Then the license is removed from that machine, and you can then go to your other computer, and using the online login and order number that you have, you can then activate that same license on a second machine. That's also applicable to Global Mapper as well, by the way. And also, we have for several years been making under the hood updates to the software to maximize Windows 10 compatibility, that gives us better memory management, among many other things. You won't see much of that in the 2020 applications. It's all behind the scenes. Some of the visual aspects of it happened back in the 2019 release, even back as far as 2017. So with the 2020 release, that project, even though it's ongoing, is really coming near to completion. So get some better compatibility with Windows and memory management there.
All right.
Sam, before we go on, I just noticed there was one question about converting a table to vector. So I'm just going to touch on that right now. Back to the point database conversion job, you'll notice that there is on the output, you can select as reshape as an output format. So you can convert one column of coordinates to the geometry in a shape file, and then the other columns will come along as attributes.
Okay, yeah, I definitely should have mentioned that. Sorry, I think I accidentally jiggled my mouse there while you were going. I let go as soon as I realized what I was doing. Back to the interactive conversions. Some of the new things that are a little more visible than memory management. I know everybody likes memory management stuff, but some of the stuff you can actually see in the application. We've added some new magnetic models. These were added by popular request, and so to talk about these a little bit, if you're looking for a magnetic model, where do you actually see these things show up in the application? These are something that we have turned off by default. So folks that want to work with these, you'll need to go into your preferences. So under the options menu, get into the preferences, and in there, you'll see a checkbox to display magnetic declination. And when you turn that on, you'll see there's a little drop down that has 7 different models that we support here in the application. Now, with these different models, it's basically a very common choice. It's not quite like working with a coordinate system that you're going to want to change this all the time. So we've included these up in the preferences for now, and if more and more of these get added to the database, maybe we'll change this. But for the current workflow, you'll see there's these 7 different models. There's 3 of the IGRF models, so IGRF 11, 12, and 13. And then there are world magnetic models. So IGRF is International Geomagnetic Reference Frame, one of our nice long geodetic mouthfuls there. WMM is then a world magnetic model. So you'll see that there are several series of each of these, and they have some distinct differences. Lastly, up at the top there is GUFM, which does not actually have, it looks like an acronym, but it is not commonly treated like an acronym. It doesn't have a full version, if you will. Its name is actually GUFM1. The IGRF and the World Magnetic Model are essentially 2 sides of the same coin. So the IGRF model is retrospectively updated based on historical data that has actually been observed. So the date range for those goes all the way back to 1900 and up into the current day. The World Magnetic Model is based on some of those same data sets, but is only valid for a 5-year period. So the 2010 model there goes from 2010 to 2015. 2015 model goes from 2015 to 2020, and then 2020 goes for the next 5 years. So from 2020 now until 2025. So these are predictive models in the World Magnetic Model, and the IGRFs are all basically historical models. There is some overlap built into those. They are essentially very, very close to the same thing. Depending on who you are, if you work for certain government and national agencies, you have guidelines that tells you which one of those you should be using. But for most folks, if you are working within the overlapping time periods, the choice is essentially arbitrary. They're really academically splitting hairs between what they've measured and what they are modeling out. The additions that we've added here are IGRF 13 and World Magnetic Model 2020. And as actually as Scott shared with me the other day, I didn't realize this, but IGRF 13 is not 2013, that is the version number 13 of that model. So the version numbers do not correspond with the year there, whereas the World Magnetic models do. So these choices, when we select one of these particular magnetic models, let me back up one step here. First, to make sure that you actually have the ability to do these, you'll need to have time-dependent transformations turned on here as well. And you've heard me talk about years a few times when these actually work. We do need to be able to assign a date with our coordinates in order to have these show up. So when we add those on, you'll see a new field for magnetic declination automatically populates for the data points that we've done out. So these are available here on the interactive job and also on the point database conversions job. Magnetic declination varies all over the world. It's not, it's very much like scale and convergence. It is unique values all over the place. The strange thing about magnetic declination is that it moves around, and that's why these models need to periodically be updated. If you are totally new to magnetic declination, you don't really have a firm handle on it, we have actually added a new blog post just recently in preparation for the addition of those new models. So if you go to our website, you'll see we have a new blog post available describing some of the magnetic models and also with links to further reading, because there's a lot of really interesting stuff about these magnetic models. So that's the two new magnetic models that we've added in here for support. Also, there's a lot of work going on here in North America about updating our coordinate systems for the US and also Canada and Mexico are working on a three-way partnership to modernize our coordinate systems that we use for referencing here in North America. One of those big new updates is the addition of a geoid called Geoid 18. The full name of that is the US geoid model of 2018. What this model allows us to do is get from an ellipsoid height from something like WGS84 or NAT83 over to our national survey datum called NAVD88, the North American Vertical Datum of 1988. Here in the States, we have a number of different geoid models. And now I'm just going to call out that we have, you'll see all of these that are in red here. The red with the exclamation point indicates that those are models I don't actually have locally on my machine here. You'll see I've downloaded the geoid model of 2018. The reason I only have that one on my machine at this point is because this is the new survey standard. So folks working with vertical datum information that they need to report officially for surveying purposes. The geoid model of 2018 is the current survey standard and best practices to get to our North American vertical datum of 1988. The reason I don't keep all of these on my machine is because the grid files actually do take up a little bit of space. And once you've moved on to a new survey standard, you really just don't need the old one anymore. The geoid model of 18 is effectively all we need right now. If I am going back and doing some historical work and I need to undo something I did in the past, I can download these at any time. All of the ones that you see in red, all you have to do is simply right click on those and you'll see download missing files. That reaches out to our FTP site and will automatically download they're in a compressed format for download that will automatically download them, unpack them, and then you'll instantly be able to use those in the Geographic Calculator and Global Mapper if you have the two tied together. So there's really nothing particularly unique about this model. It does actually, if you note the type of model, this does actually use the same grid structure that they've been using since 2003. It is simply based on the latest and greatest data. Now, one of the setups for Geoid 18 is that this is going to be the last update for the United States geoids until the major release of the 2022 coordinate systems. So what the NGS has shifted to now is working on the temporal portions of how our vertical datums are moving dynamically, just like the horizontal systems are moving through time. So there's going to be some exciting stuff coming in here. This is sort of like that last major milestone before we get the updated systems in a couple of years here. Once you have the grid in place, again, it's just a matter of selecting your input and output coordinate systems and finishing off your calculation. And oops, I neglected to put in place my magnetic model. That was a little bit silly of me. Turn that back off. Giving me a warning that I was missing that grid file. The vertical datum component right here is what we're looking at, and that comes just like any other vertical datum. So the latest and greatest survey standards from the NGS there. And then lastly, also while we're on here, I just want to mention NADCON 5. So NADCON 5 is, it's not actually a new feature in this, but a lot of folks are still coming up to speed on it. When I was stepping through our datum transformation early on, you'll see I had that list of 5 different ways to make the transformation. And the one I selected was the NADCON method. So this is the old NADCON method. NADCON 5, you'll see this new specialized one here at the bottom. NADCON 5 allows us to take advantage of the new survey standard from NGS for transformation. And this is a very special set of transformations here. So this uses a whole series of transformations to get from NAD27 up into the modern epochs of NAD83. The transformation I have here, NAD27 to NAD83, that is actually a direct link. So if I pick this particular combo and I say OK, you'll see there's one transformation listed. Now, if you've done any reading, any learning about NADCON 5, I'm just going to flip over to this is a NGS technical document where they describe how NADCON 5 works. Each one of these blue nodes on this horseshoe-shaped thing are different realizations of the North American datum. So from here between 2 and 3 all the way out to 6, these are different realizations of NAD83. Until NADCON 5, there has not been an easily direct way to get between each of these. And the reality of it is if you want to go from NAD27 to NAD83 Epoch 2011, which is our current survey standard, you have to go 1, 2, 3, 4, 5 steps around the horseshoe. So that's 5 datum transformations to get in between there. NADCON 5 is what allows us to do that. Now, from NAD27 over here, I'm just going to change up my coordinate system to NAD83, and I'm going to grab on to the NAD83 2011 realization. Now, when I go to make this datum transformation, you'll see there's actually only one way that I can do that, and that is via NADCON 5. When we pick that transformation, you'll see it is going to do all 5 of those steps in the center here to calculate our ending location. That encompasses that basically the 30 years of movement between NAD 8386 and where we are in the current epoch, and allows us to make a transformation that up until NADCON 5, it just wasn't practically possible. You would actually have to do a series of 5 different transformations in here to get that done. So that is a sort of a major new piece that is laying the groundwork for those updated coordinate systems that we expect to see in 2022 here in North America. And just one note, NADCON 5 is also available in Global Mapper using the Geographic Calculator GeoCalc mode in there. All right, so Scott, I think you're going to tell us a little bit about some new LiDAR conversions that we've enabled.
Yes, so as is often the case with improvements to Calculator, the user had requested the ability to convert LiDAR data directly from one best fit engineering coordinate system to another at the same site. Now, there have been a couple of questions about best fit I've seen come in. So maybe quickly I can just mention that the best fit job, I'll bring that up. We have local coordinates and known coordinates measured in a known system, in this case, UTM 15 north in, excuse me, WGS 84. So these would be local engineering survey coordinates. And one of the questions was about best fit, and you can see the math transform here, and we have a number of polynomial fit functions that we can use to generate a transformation between the local site and the known UTM coordinates. Excuse me. Now, what we're going to do in this case is, where's my LiDAR job? The user had LiDAR data that was probably collected in WGS 84, but had been converted to a local engineering system. So if you were handed data in that system, then you have to work with that. Now, if they gave you those best fit coordinates to get you back to a known system, in this case, we're going to use NAD 83 UTM zone 19 north. So I have a best fit system, and a best fit coordinate system really is, it contains the transformation coordinates to get between the local site and the known system, NAD 83. So we have one called Hollow L1. So perhaps you were given that information, and I can, rather than use the best fit job, I can build a best fit coordinate system. In this case, I used a Helmert 4 parameter with just translation parameters to get between the two. Now, maybe a second survey is done at the same site with a different origin point, possibly orientation as well. In this case, I just did a simple offset of the origins. So Hollow L2 over here that I have on my target side is a second best fit system, also to NAD 83 UTM zone 19 north. And that's important, that both of my best fit systems have the same base known system. And because they do, I can now convert directly from one local engineering system to another. And that was not possible in the past. So we have a little sample LiDAR data, Hollow L1, and we can process this, and going from Hollow L1 to Hollow L2, file already exists. I'm just going to overwrite it. I'm finished. And I can then view these two files. And Hollow L1 is the one to the south and west. And that transformation that I just did, conversion, has shifted those data about 60 meters to the east and 35 meters to the north. So if those, would go from the original survey to the new survey system. As a side note, these coordinate systems, the best fit systems, Hollow L1 and Hollow L2, I created those on a different computer. And Calculator has an import and export function as an XML file. We use the extension XSP, but what this does is it creates a self-contained file that has all the fitted parameters, and then anything that it relies on, for instance, the NAD 83 datum, the ellipsoid, all that information is packaged up together in this XML file. And then I can copy that and import it into a different machine, this one, and those systems become available. If I go to data source, coordinate systems, and look in the fitted folder, There are the two systems. They're blue because they're custom systems that I've imported. So I built those on one machine, exported the whole package as one XML file, and imported on this machine. A very handy feature. Okay.
Okay, that's great. So I know we have a lot of users, particularly in the mining industry, that I think are gonna find some use with that as LiDAR gets more and more common in that industry. I know I mentioned airports earlier. Basically, any place where you've got a use of LiDAR and you have multiple series of those localized grids, I think that's going to be a great tool for some of those folks. So now, earlier I mentioned this change that we've had in the calculator. For a very long time, the calculator has been a late bound application. So we have the ability to recognize the difference between a datum and a distinct transformation that links up different combinations. That really lets calculator be a very, very powerful tool for geodetics transformations. But there are still so many other tools out there that rely on early bound technology. Interfacing with those applications has been a challenge for us because when you import something from another location, it comes in and we break off the transformation and you get two separate things. And doing things like import and export from, say, the Petrel CTL database for folks of you who are working with systems like that, where we can read in and manipulate that database, but we needed the ability to be able to do early bound transformations again. So we have spent a long time now sort of putting the ability to early bind a transformation, but to do it safely. So to take advantage of all the spatial admin settings that we have to be able to set things up in a way that folks can work with those early bound coordinate systems, but also use them to make the right choice. Now, I'm going to just set my coordinate systems back the way they were here. So I'm going to go back and get my NAD83 coordinate system. And I'm going to come in here and pick a different coordinate system. So NAD27 via NAD27 to WGS84. You see I've got this blue custom coordinate system right here that is an early bound transformation. So this is a new component of the application that we've are just releasing in this version. When we take one of these, you'll see there is a base system. So this is relying on NAD27 geodetic, and we associate a transform with that. So this is the datum transformation. And so we're saying this is one attached entity. We can pick this transformation pick this early bound coordinate system. And by picking that, we are picking that and the transformation that we want to use to associate that with its target system or systems. So we have a sort of a hybrid ability here to work with an early bound and a late bound system at the same time. So this NAD27 is linking NAD27 to WGS84. And you'll notice my transformation out on the main screen is actually to NAD83, not WGS84. If I go to pick a transformation in here, you'll see it actually asks me how to get from NAD83 to WGS84, because we already know how to get from NAD27 to WGS84 from the early bound transformation. So if I select this single transformation here, and say OK, you'll see two transformations pop up. One is the transformation that came along from our early bound coordinate system, and one is the other piece that I need to get out here to my NAD8386 system. If I were to change my coordinate systems and go out, just say straight to WGS84, and make that same link, you'll see it does not pop up. I double clicked here and it does not pop up a choice because the early bound system already covers it. So it gives me from that choice right there, I don't then have to choose any other transformation. This is lit up throughout the entire application. Any type of datum transformation that we have, any type of coordinate system, whether it be lat long or projected systems, can be early bound. And the method for that is really quite simple here. down under coordinate system definitions in the data source. If we get into our North America folder, you'll see what I've done here. So there's the new early bound system. Early bound systems do need to be turned on in your administrative tools. There's a checkbox to turn those on. And when you have that, you can grab any existing coordinate system. You have to start with an existing coordinate system. And there is a new button down there for promote to early bound. And when we do that, it basically asks you to associate a transformation with that, and that will create your new system. So we can pick any transformation. I'm just going to grab one willy-nilly here for sake of demo. And then it allows you to create that early bound system, and you'll see the new entry in blue there with that early bound set. Again, as Scott mentioned, you can export that between users and put that on any number of machines that you need to. Very commonly, that's something that's going to be used more at the enterprise level. Okay, and so speaking of enterprise data source management, Scott here, you want to tell us about the new features of the enterprise data source?
Sure. We've added a new method of data source management for enterprise-wide deployments, including an automatic update function to keep users in sync. So administrators can now maintain a customized enterprise data source on an Azure web service. The coordinate reference systems and transformations in this enterprise data source can only be edited by the administrator. The application can be set to check for enterprise updates on startup if desired. And I'll show you if we go into Options, Administrative Settings, on this Geodetic tab, there are now a couple of new features. The Blue Marble online registry is there by default, but we can add a new registry. And if we have an Azure URL, we can enter the information here, give it a name, the URL, credentials. And then if we want the user to have that be updated on every startup, checking for updates, we can check this box. Related to that, there's a new streamlined way of handling the view. Now, the view is the file that manages the organization of the data source, the folders, the locations of the coordinate systems and coordinate transformations in those folders. So that view file is now stored with the data source rather than within a workspace as it had been in the past. So the new view functionality is backwardly compatible because if you load an older workspace that has a view file, it will be merged with the view in the data source, or one will be created if one hasn't been created yet. This change is mainly useful for administrators and largely invisible to regular users, however.
That definitely is one that's not for everybody, but for those of you who are setting up the enterprise databases at large organizations and you're doing the management for other folks, we really think you're going to like that little last piece. So just the last little couple of things to talk about here. There's another new feature where we've improved the ability to get to printers. This is just a little quick one I'm just going to mention. You can now choose a non-default printer. For a very long time, it's just automatically reached out to whatever your default printer was, and it would send anything you've printed out to that location. Now there's a new selection for actually making that choice. The last little thing that we needed to tuck in there. As always, we've done our Epsg updates. The latest revision that we've got in place now, we are fully in sync with Epsg dataset 9.8.7. So as always, many new coordinate systems are coming in, new methods, all the latest and greatest geodetics. And I think that is pretty much going to wrap it up for the main chunk of our talks here. So before we get to questions, I just want to say thank you all for attending. We love talking about our new features here in Calculator. If you have any extended questions, so things that we haven't gotten to here in the session, if you have any questions about the status of your subscriptions, any pricing or upgrade related issues, feel free to reach out to orders@bluemarblegeo.com. And if you have anything that's more on the technical side, so maybe some of the new features you want to learn more about how to actually operate them. If you have any more in detailed questions about how to do particular jobs that we haven't had time to talk about today, please reach out to our tech support group at geohelp@bluemarblegeo.com. Again, we also have our new blog post on magnetic models if you want to read a little bit more about some of those. And there's a number of other blog posts that you may find useful up on our website again. So let's get out to some questions here. All right, let's see. We've had a lot of great questions come in, and we've tried to answer some of them as we've gone. Let's see here. I think we talked about several of these. There's several of you have asked questions about how do you know if you're eligible for the new upgrade. And the generalized answer is if you currently have a working geographic calculator, you probably have a valid subscription. We do have a combination of some folks on subscription licensing and some folks on perpetual licensing. But if you're not sure if you're on subscription, you don't even know what kind of license you have, that is entirely common as well. Those folks, I would actually suggest what I just mentioned. Reach out to orders@bluemarblegeo.com. If you give them your basic contact information, if you have an order number available, those folks will be able to tell you the status of your subscriptions or perpetual licenses or whether or not you get the upgrade. But chances are, if you've got a working calculator right now, you're probably in a maintenance subscription with us. Let's see here. I understand. I'm just going to read this one out because it's a little bit longer of a question. I understand from Blue Marble support that we require GeoCalc to apply geographic datum transformations to streamed online data such as SRTM or world imagery. Can you please describe how that works? If I was to apply this to a shared workspace, will other GM users observe the changes? So talking about the mashup of GeoCalc mode in Global Mapper and Calculator working together. If there are particular transformations that you're after that are, let's just talk quickly about the what's and the whys of GeoCalc mode. I'm going to back out of my slides here and let's bring these two together. Presently in Geographic Calculator, there are a number of different datum transformations, projections, and methods for things that are not supported natively in Global Mapper. Those major categories of those include things like NADCON5 transformations, but that also includes things like vertical datums. So if you are if you're working with elevation data and you're trying to put those on different geoids, that's one major reason right off the bat to bring those two together, to have Calculator alongside Global Mapper. Once you get familiar with both of those applications, you'll find that some things you may rather do just on one side. So you might want to be working in Global Mapper with GeoCalc mode turned on, or you might want to be working over in a batch context in Geographic Calculator. It really kind of depends on the particular thing. The changes that you will make in Global Mapper. So if you're they're specifically asking about your workspace there. If you take a piece of data and you apply a transformation to that data and you change the base data itself and you save that into a workspace, you will have manipulated your data, and that's something you can then export to another user. It does get a little trickier if you are trying to do things like on the fly, use something in Global Mapper that is supported in GeoCalc mode, but not supported by other Global Mapper users who don't have that. What I might recommend is reaching out to our tech support group with the nitty gritty of the specifics of what you're trying to accomplish, and we can go into much greater depth on that answer. But in general, if you're working with data sets that you want to locally download and apply a transformation to, that will change the base data, and then you can pass that on to anybody else, and they'll see the source data actually changed itself. Let's see. Another question came in about the best fit job, as we were talking about that. The question is, I take it that the point database best fit employs methods of least squares. The best fit job, basically yes is the short answer. The longer answer is it supports a few different polynomial models. Most folks work on a basic affine transformation, but there are higher order polynomials that Scott mentioned a little bit as well. So there's we go all the way up to fifth order polynomials. There are also a couple other methods that can be applied in there manually. So if you have things like Helmert four parameter transformations or conformal 3D transformations, those things can be applied manually in there as well. Let's see here. More questions bringing Global Mapper and GeoCalc back together. Let's see, when can we perform coordinate transformations between different data sets if they're opened in Global Mapper or on the final data processing? When you bring data in, assuming you are working in GeoCalc mode, it actually works fairly similar to the native support. So it will, on the fly in the application, it will perform some of those things like projections. As you know, if you have disparate horizontal projections that you're overlaying, it will do that on the way in. But it doesn't actually convert the base data itself until you go and do an export operation on that. Calculator is a little bit different from that in that it doesn't have the concept of a workspace in the same way that Global Mapper does. You're not building a map and you're not overlaying data. Calculator is essentially a data conversion application. So bringing those two together, they have some slightly kind of different conceptual workflows, but in Global Mapper, it will do both. So it will allow you to overlay your data on the way in, but it doesn't finalize that until you actually export that data out as a new file. Let's see here. Some questions. There's a few questions on time dependency. We didn't really go too deep on that, and that will probably be a topic that we're going to come back to again for another session. But just very briefly here, time dependency. If you have that turned on, and it is turned on by default out of the box, under your coordinate systems, you'll see this date field. If you select from the category of coordinate systems that are capable of being connected with a time-dependent transformation, it works just like any other system. So if a time-dependent transformation is possible, it will show up when you go to pick your coordinate transformation in the center. What you need to do there is pick your date on either side. So you need the epoch you're coming from and the epoch you're going to. We have combinations in here of horizontal time-dependent positioning. That is an NGS toolkit that allows you to move between the ITRFs, the WGS84s, and the NAD83s in the North American area. That is able to do both a frame shift as well as the temporal shift. So it actually does three things under the hood and then pops back up the other side on a different epoch on a different reference frame. Some other transformations that are a little simpler, like a 14 parameter time-dependent transformation, such as very common in Australia, actually. These transformations allow for essentially doing one piece of that. They do the time shift, and we're still working on the application infrastructure to be able to chain these together into more complex links, but right now essentially it goes from one frame to another frame within that epoch. So the main pieces there are you need to have the dates turned on, and just in case those have maybe gotten turned off in your application at some point, under the preferences, you'll see under the general preferences, you'll see enable time-dependent epoch-based transformations. You need to have that toggled on, and if you do have that toggled on, you'll see the date fields light up with your coordinate transformation. Then if you are in a part of the world and your datums have transformations defined for them that are time capable, they will show up when you go to do your coordinate transformation. As always, as we get talking about specifics of any transformation, if you have a particular combination of systems that you're working in, I would encourage you to write into tech support and ask for how to work with that specific group, because it does depend very heavily on where you are on the planet and the combination of systems that you're working in. Let's see here. I think we'll take probably just a couple more questions, and then we may need to follow up with some of you by email after the fact. I've got a couple folks inquiring about 7-parameter transformations, whether or not we support those for 3D transformation. There is a toggle actually with any datum transformation, whether or not it is a 3D transformation in itself. So there are 7-parameter transformations that are simply 2D, and there are those that are 3D. It depends purely on the setting, and I'm gonna go out on a limb here and see if I can really quickly find one. Let's see here. Here is an Australian one. It is a 7-parameter transformation. This is the checkbox you'll see up here. So is 2D. So if the checkbox there is 2D, then that is not a 3-dimensional transformation. If you have a particular transformation in there that has that unchecked, then that is a 3D transformation, and it will manipulate your elevations if you apply that to a transformation that you're doing. So again, if you have a particular example you're looking for, tech support would help you get set up with a particular combo you're looking for. Sometimes there are transformations that are standard that folks want to use in a 3D context, knowing that it is actually a 2D, and you can make a custom copy of that. We can help you get set with that if that's something you need to do in your database. Some questions on the new GeoID 18. So if we've got some data on the older systems, so specifically GeoID 12A, and I'm going to extend that to say any of the old geoids. If you have the elevations that are based on any of the previous geoids, it's very, very common. Can you strip that off and add in GeoID 18? And yes, that is exactly what happens with any of the vertical datum transformations. You can just simply wind back your geoid. You have navd88 for input and navd88 for output, and you'll actually see when you go to pick a transformation that you'll have all of those combinations of vertical transformations. So you would want to pick the combination that would first apply GeoID 12A and then apply GeoID 18. You would need both of those grids downloaded before you actually fire that off. But you've probably already got GeoID 12 if you're working with that, so you would just need to download the additional GeoID 18. Let's see, there's a few questions about specific data sets in Global Mapper, and that's a little bit outside the realm of what we want to get into in this session. But I will just simply say if there are particular data sets that you need access to in Global Mapper, on the streaming sources, we've talked a little bit about streaming sources. Please reach out directly to our tech support group at geohelp@bluemarblegeo.com, and they can help you get set up bringing in any of those custom data sources. And I think we are just about covered in there. There's a few questions we've been trying to take some as we go. So I think we've gotten to most of these. If I haven't answered your question, we will be following up by email afterwards. All right, I think we're going to call that good. And it looks like we've gotten to all the questions. I want to thank everyone for attending today. Thank you, Scott, for co-hosting with me.
My pleasure.
And we will see you next time.